Imagine you have a music playlist with a million songs. अगर मैं आपसे कहूं कि इस पूरे प्लेलिस्ट को शफल करना है, how would you do it? Will you move one song at a time? No way, right? That would take forever. दोस्तों, डीएसए भी कुछ ऐसा ही है. It's not just about moving data, it's about finding the hidden patterns to do it in a flash. Hello friends, I am Supratim, your coach at Techmine Guru. Welcome back to DSA, the complete journey. आज हम एरेज के आर्ट ऑफ मैनिपुलेशन को मास्टर करेंगे. नो मोर ब्रूट फोर्स, ओनली स्मार्ट कोडिंग. आज का सेशन 3 लेवल्स में डिवाइडेड है. द कोर टूल किट, जहां हम सीखेंगे एरे रिवर्सल को मास्टर करना. द रोटेशन चैलेंज, हम एक स्लो ब्रूट फोर्स सॉल्यूशन को देखेंगे और वी विल ट्राई टू कन्वर्ट इट इनटू ब्रिलियंट ऑप्टिमाइज सॉल्यूशन, राइट. आफ्टर दैट फाइनली हम देखेंगे dynamic arrays. So grab your notebook, let's begin. So our agenda today will be array basics, reversing an array, rotating an array, and what are dynamic arrays. So let's start with array basics. So what is an array? Array is a sequential collection of same type of data. Sequential collection. So we define array like int array of n. Let's take an example to understand it. So we have an array of 2, 2, 4, 5, 6, right? So in array, index always starts with 0. So first value at index 0 will be 2. Second value at index 1 will be 2. Third value in index 2 will be 4, and so on. So this is referred as array of 0. This 2 will referred as array of 1. This will be referred as array of 2, like that. So let's understand how to print all elements of an array. So for that, we have a function print array, which will take array as an input and n as the length of an array. So for this, we just have to loop from I is equal to 0 to n minus 1. Why from I is equal to 0 to n minus 1? Because array index starts from 0 and it will go till last element. So last element will always stay in n minus 1. The for loop will start from I equal to 0 to n minus 1, and we will print each element of the array, because to get access of the particular element, we need that index only. Since the for loop is running from I equal to 0 to n minus 1, so what will be the time complexity? So n minus 1 minus 0 plus 1, which will be n iterations. So time complexity will be O of n. And to access an element in an array, we need that array index only. So the space complexity will be O of 1. Now let's understand, if we want to print the sum of first and fifth element of an array, do we need to iterate the array? No. So first element we can access via array of 0. Fifth element we can access via array of 4. So the answer will be array of 0 plus array of 4. Now let's understand how to reverse an array. So given an array of size n, and you have to reverse it. But there is a catch into it. You cannot use a second array to store the result. You have to do it in place. So the space complexity in the constant is given as O of 1 you have to do. So let's take the example of the input 1, 8, 3, 6, 5. The output will be 5, 6, 3, 8, and 1. So let's understand how we can do that in place. So for this, we have an elegant swapping mechanism using 2-pointer technique. So the strategy here will be, we have to take 2 pointers, I at the start and j at the end. As long as I is less than j, we need to swap the elements. So the first element will go in the last and the last element will go in the first. And we have to keep doing it till we have I is lesser than j. And for moving the pointer, we need to increase the I and decrease the j. So whatever we have understood the strategy, let's see the code for that. So this is the reverse function where we have taken array ARR as an input with n as the length. We will take the first pointer I equal to 0 and second pointer as the last of the element, which will be n minus 1. Here I have used while loop. Here we will run a loop from I is less than j, since we have to stop at that point. And this is the swapping logic. In this, the element pointed by the I pointer is stored at temp variable. then we can move the j pointed element to the I pointed element, and then again when j is moved to I pointed element, then we have to put the ith element to the jth element using the temp variable, and then we need to keep doing it till we reach this condition. That is, we have to move forward the ith pointer and we have to move backward the jth pointer. So our number of iterations for I will be n by 2 and j also will run till n by 2. So our total time complexity will be O of n, and since we are not using any other extra array for this, we are just using this temp variable, so the space complexity will be O of 1. So we have reached our goal, right? Now, can we reverse only part of an array? Yes. So what is going to change in the above code? Only ith and jth pointer, which was starting from 0 and n minus 1th index, it will start from the start and the end index. So now the loop running will be the same. I is less than j. We will swap. The swapping logic has already been defined here. And then we will move the I and j pointer. So the time complexity will remain same, O of n, and space complexity will be O of 1. So this function will give you reversing an array from start to end index. So let's take an example. Array 1, 2, 3, 4, 5. Start index is 1, end index is 3. So just we have to reverse this part. So here start will come as 1 and end will come as 3. So 2 will be swapped with 4. So 4 will come here, 2 will come there, and 3 will be as it is. Since I will start from 1, so I will stop at 2, and j will start from 3, it will also stop at 2. So this condition will break and we will come out of the loop. So finally the time complexity will be O of n and space complexity will be O of 1, because we are just taking one temp variable inside the swap function. Now let's level up. Let's see how to rotate an array. So you have been given an array, you have to rotate it from left to right by k steps. So your input array is 1, 2, 3, 4, 5, 6, 7. If you rotate it from left to right by 1, your array will look like 7, 7, 1, 2, 3, 4, 5, 6. And if you keep doing it 3 times, you will get the output as 5, 6, 7, 1, 2, 3, 4. So let's think of a brute force approach. So what could be the brute force approach for this? So brute force approach will be, you have to create a loop that will run k times. And inside that loop, you have to shift every element to the right by 1 position. So if we take an example where n is equal to 5 and the original array is 1, 2, 3, 4, 5. So after one shift, one rotation, you will get 2, 3, 4, 5, 1, right? After second rotation, you will get 3, 4, 5, 1, 2. After third rotation, you will get 4, 5, 1, 2, 3. Simple, right? So in this, we are running a loop from I equal to 0 to k minus 1. And in that, we are keeping the last element in a temporary array, because we are shifting. When we are shifting, we will always swap the last and the first element. We are keeping the last element as a temp, and now we are running a loop from j equal to n minus 1 to I, so that we can shift each element by to its right position. So a of j minus 1 will be equal to a of j, and when this shifting will be done, we will be left with the last element and the first element, and we can swap the loop. And how many times we have to do? We have to do it 3 times, right? So what is the problem in it, in this approach? So we are shifting n items every time. So it will take, this loop will take n iterations, which will be equal to O of n times. And we have to keep doing it till we rotate it k number of times. So we are running a loop from 0 to k minus 1. So this will run till k times. So what will be the time complexity? O of n cross k. And here we will get the time limit exited for larger input. Suppose we have n ranging from 1 to 10 to the power 6, 1 to 10 to the power 6 n, and k ranging from 1 to 10 to the power 3, right? So in that case, our number of operations will be 10 to the power 9, which will break our golden rule of keeping it less than 10 to the power 8, right? Because every time we will proceed more than 10 to the power 8, we will get a chance of time limit exceeding. So what is the solution for this? So let's see the optimized approach. So just now we learned about how a reverse operation works. So we will use that in place reverse operation to rotate array k times. So just we need to understand the pattern inside this. So there is 3-step process for that reversal. Let's say we have 1, 2, 3, 4, 5, 6, 7. So in the first process, we will reverse the complete array. So what it will be? It will be 7, 6, 5, 4, 3, 2, 1 after step 1. Now we have to reverse from 0 to k minus 1. What we will get by reversing from 0 to k minus 1? We will get 765 as 567. Now we will reverse the remaining part, which will be from k to n minus 1. So 4, 3, 2, 1 will become 1, 2, 3, 4. So the final result we will get is 5, 6, 7, 1, 2, 3, 4, which is exactly what we are getting in the brute force, but without running one extra loop. So you just have to find the pattern that from where to where, from which range to which range you have to reverse, and you will get the answer. This approach was for rotating an array from left to right. What if the question says you have to rotate the array from right to left? Since we know that if you have to access any element, suppose you want to access k, so from the left, which number it is? It will be into 2, right? And from the right, which index it is? It will be 5. So you just have to remember that since we are rotating from right to left, we have to keep k as n minus k. And in that case, just we need to reversing of the array at the last. So rotating from left to right will be step number 2, step number 3, and then step number 1, and you will get the answer. You can try it with pen and paper and you will reach the exact thing. So that time reversing first k elements will be 0 to n minus k minus 1, and reversing remaining elements will be n minus k to n minus 1, and you don't have to touch this one. So this will be 0 to n minus k minus 1, and this will be n minus k to n minus 1. That's it. So what is the time complexity here? So your first reversal is running from 0 to n. So the time complexity will be 0 to n, O of n. The next reversal is running from 0 to k minus 1. So the time complexity will be O of k, and the next will run to n minus k. How? If we still remember from our first or second lecture, so how to find the number of iteration in this range? N minus 1 minus k plus 1, because the formula is b minus a plus 1. So n minus 1 minus k plus 1. This plus 1 will cancel. So the loop will run from n minus k. So the number of iterations will be n minus k. So the time complexity will be O of n minus k. So if you add up all this, you will get a simplified result. This minus k and plus k will cancel each other. We will get O of 2n, which is again O of n, since we are ignoring the constant coefficient. Since you are using the in-place reverse logic, your space complexity remains the same, which is O of 1 in this case. So we have reduced our time complexity from O of n into k to O of n. So this is a massive improvement, and it will avoid the TLE. Because now, no matter what is the size of k, we are not dependent on size of k anymore, but there is a case to handle. So let's see by example, what is the case? What if k is very, very greater than n? So if you see properly, you will see that if k is equal to n, we will always get back the original array. Let's see how. Suppose let's take k as 5. So for k is equal to 0, it will be 1, 2, 3, 4, 5, and 0 mod 5 will be equal to 0. K equal to 1, it will be 2, 3, 4, 5, 1. When k equal to 2, it will be 3, 4, 5, 1, 2. Similarly, k equal to 3, k equal to 4, and in k equal to 5, you will again get the original array. So we can see that when k is equal to n, the same pattern, the original array will get repeated. So we are just worried k is between 0 to 5, right? So for this, if k is equal to n, we can use a modulo operator, which can tell that how many iterations we need to do. So suppose n is 5 and k is 8, right? So 8 mod 5 will be 3, right? If you see till 5, we will get the original array again. Then if k is equal to 6, we will get this. If k equal to 7, we will get this. If k equal to 8, we will get this. So 8 mod 5 will give you 3. So that's why we have handled it with a edge case telling that if k is greater than n, k will be equal to k mod n, which will give that how many times we are rotating it. Because whether it is 8th rotation or 9th rotation, if we modulo it with the size of the array, we will get the exact number of rotations we have to perform, right? Now, in this, we are seeing array, which is static array. So what if we need size of the array to be dynamic? So the only problem in static array is that their size is fixed and you have to create it initially. So what if you want more space? The solution is using the dynamic arrays, because dynamic arrays will internally resize when they get full. We will learn that in other classes. So how we will do this in our modern languages? So for that, in Java, we are using array list. In C++, you are using vector. In Python, you are using list. And the list continues. आज आपने सिर्फ कोड नहीं सीखा, you have leveled up. आप in place reversal सीख गए, how to use brute force approach and what are the limitation of that, and how to optimize that code, how to do a in place reversal, and how you can use that reversal algorithm in doing the rotation, which we saw in the optimized method of rotating the array. Now you are not only using the array, you think with them. Next video में हम unlock करेंगे prefix sum arrays. हम सीखेंगे कि कैसे complex problem को constant time में solve किया जाता है. अगर आज का वीडियो आपके लिए helpful था, तो please subscribe to Techmine Guru. With this, I am Supratim signing off for today. Keep coding, keep learning, keep optimizing.